Hello and welcome to another one of my thoughts videos. Now, last time I was talking about my cup of coffee and the investigations that led me into the understanding of atoms and how things are put together. In high school, they told us of the periodic table, which we thought was absolutely boring and of no use at all, but in actual fact it's quite a good thing. It was the idea of protons, neutrons and electrons forming an atom, and then adding different numbers of protons, neutrons and atoms, getting different kinds of elements. And they started off with that basic theory well over 150 years ago, but it took them quite a long time to figure out which of those numbers of, there were big gaps in the table until they could figure out what those atoms actually were in reality, in the real world. And they've amplified that till we have quite a solid understanding of how that might work. Now, all of this is theory. It's very hard to prove because you can't see it because they're so small, but the theory is that you try and prove by cross-referencing experiments and proofs and things, and over 150 years they've found that the idea or the concept of atoms, the proton, neutron and electrons, and they're looking at other things, but it's reasonably solid for us to basically more or less trust. Now, the component of those atoms, starting with one proton, one neutron and one electron making hydrogen, that is the basis of our stars, our sun, the light we see. It's the basis of the beginning of life, with that beginning of the one neutron, proton and electron. Well, when you start to combine those atoms, that's the next step. And in my coffee, we're going to look at some more complex thing, but the first one is that of water. Water is a very important thing for us, and it's made up of only 3 atoms, which are even better. There's the hydrogen, which makes our sun, which gives us life, and oxygen, which we breathe and is extremely useful for all sorts of things. Now, if you take 2 hydrogens and 1 oxygen and stick them together, you get water. Let's look at that. Now, when the universe was created, there were all these little particles nicely balanced, and they were neutral and they are neutrons. But then all of a sudden we have protons. Now remember that protons have a positive charge. That's what they're called, pro, and they, because of the laws of attraction and repulsion, they begin to attract to the neutrons. But when they attract to the neutrons, because the neutrons are neutral, the little clump here becomes positively charged. Now, the attraction, once again, there's a third kind of particle, which is the electron. Because we have a neutral neutron, a positive proton and a negative electron, they balance out by having an electron and a proton with the neutron, and that makes it balanced. If you were to put it in a nucleus, it would look something like this, I suppose, in the concept anyway. We have the nucleus and we have the protons and neutrons and the electron there. Now, we actually have in this first ring space for another electron, and that space is illustrated here. The small atom, as I've said in other videos, electron, proton, neutron, there is a hydrogen atom. Now, if we add another proton and a neutron, we get 2 protons, 2 neutrons. That means we have space for another one, and that will another electron, and that will give us a helium. But what we're interested in, if we keep on adding those, we have to have another layer because only 2 can fit. So we have another layer, and in that layer there is space for 8. Now, if I was to add another 6 of those, that would give us an oxygen. Let's pile those on there, and that would give us space for this many electrons. 6 2 on the inner ring and 6 on the outer ring. But as you notice, there are space for another 2 electrons, and that's what makes it useful. So if I have a hydrogen here, and let's swap that by putting that one there. And there's our hydrogen. So we have 2 hydrogens and an oxygen. Now normally they will float around quite happily apart from each other unless some reason is found to make them stick together, in which case the hydrogen and the oxygen will start to share their electrons, and they bind that way by sharing the space from the oxygens with the electrons of the hydrogens, and there we have our water molecule. Water is not an atom, it's a molecule. It's 3 atoms. So that's the composition of water, that oxygen atom and the 2 hydrogen atoms. Now, believe it or not, water is the basis of our existence. It not only keeps us in our shape like a water-filled balloon, it's also the basis of all of our energy. You thought the energy came from electricity or from fossil fuels, for example, but our existence relies on water first as the basis of our energy. Water, which we will talk about in another video, I think, can actually provide us with energy from the ambience as a basis, and we'll talk about that later. But initially, it is the basis of the fuel that we need to eat. It's the basis of the hydrocarbons, which are the fossil fuels and things. And it's you make electricity out of hydroelectrical situations and stuff. So water is the basis of our energy needs. Now they're splitting the hydrogens and the water into hydrogen as well to make hydrogen energy as well, and that's basically what a plant does to start with. Now a plant does not need any air to exist and to function. It gets its energy from the sun, but it uses the water initially to capture that energy. Let's have a look at that. Now, in the chlorophyll of a plant, which is that green substance that makes things green, well, it's actually everything but green, but it's what gives it the green colour, and there are electrons buzzing around in it all over the place. Now, from the sun, a proton comes shooting in, bing, and very fast, and it hits an electron out of the chlorophyll, and it goes spiralling off. Now that electron comes flying in, and because of the speed it's going at and stuff, it bing gets combined and starts to orbit the hydrogen atom. And that makes, because of the 2 negatives, it makes it negatively charged. The oxygen at the time, I think, is positively charged, but whichever rate, because those 2 spaces are now full with orbiting, it doesn't need to orbit another atom, this oxygen atom, and it just comes apart. The same thing happens with the other one. From more chlorophyll, the proton makes the electron come in and bing, start to orbit that hydrogen atom, turns it negative, and then it starts to just float away. And that's how the plant uses the sun to separate the water molecule into the oxygen and 2 negatively charged hydrogens. The plant can then get rid of the oxygen, and it keeps those negatively charged hydrogens because those extra electrons have energy holding them in those orbits, and that is what it's going to use. Now, the understanding of photosynthesis, which is what we've just explained, we have only known for the last 50 to 80 years, or less than 100 years, so we're a very privileged generation to know how this happens, with all the foundation of all this understanding of atomic stuff, we can figure out how the plants manage to survive. Now, the interesting thing, as you would have noticed, is that plants don't need air. They don't need carbon dioxide, oxygen, or anything. Oxygen comes as a byproduct of their energy capturing from the sun. So those hydrogens in the sun are what basically gives us the energy through plants, and the plants capture the energy by dividing the water and keeping the hydrogens and giving us the oxygen that we need later on to breathe. They don't need any air, it's just water, and that's the basis of it. And that's where my coffee and water became a mind-blowing thing for me. And it's the next step when the plant wants to store that energy, where it starts to need some air. And we'll look at that in another video. But isn't that amazing? Water is the basis of all of our energy transactions.